Hello, welcome to JD's Prep. For this problem, the vertices of quadrilateral math have coordinates m, -4, 2, a, -1, -3, t, 9, 3, and h, 6, 8. We want to prove that quadrilateral math is a parallelogram. So in other words, we want to prove that both pairs of opposite sides are parallel. If we can prove that, then we can prove that the math is a parallelogram. Okay? So, MATH, right? We need to prove, again, that both pairs of opposite sides are parallel. So we need to find the slopes, right? And what we know about slopes, if they're parallel, then the slopes are the same, right? So let's find our pairs, right? So let's find the slope between MH. Let's find the slope between AT. Let's find the slope between M and A, and the slope between H and T. Right? So M and H. Here's M and here's H. Slope formula, right, is the change in Y over the change in X. Or, let's put up in the corner here, Y2 minus Y1 over X2 minus X1. So for MH, change in Y is 8 minus 2 over the change in X, which is 6 minus a -4. And so that gives us 6 over 10, which we can reduce down to 3 over 5. Now let's find the slope of AT. Right? Choose a different color. So here's A, here's T. So we need the change in Y. So again, 3 minus -3 over the change in X, 9 minus a -1, which gives us 6 over 10, which again we can reduce down to 3 over 5. So if you notice, right, those slopes are the same. So I have one pair of parallel. Now let's find another pair. Okay, MA. M and A. Change in Y, -3 minus 2, or the change in X, -1 minus a -4. That gives us -5 over 3. Now HT, okay? My Y's 8 minus 3 over my X, 6 minus 9. That gives me 5 over -3. So again, these slopes are the same. Because the slopes are the same, that means that these two lines are parallel. So I have both pairs of opposite sides are parallel, which means that this quadrilateral is a parallelogram. Hello, welcome to JD's Prep. In part 1 to this question, we proved that MATH is a parallelogram since both pairs of opposite sides were parallel. We proved that MH was parallel to AT, and they had a common slope of 3 over 5. Okay. We proved that the other pair, MA, was parallel to HT, and they had a common slope of -5 over 3. So we know that MATH is a parallelogram. What we want to know now is we want to prove that it's a rectangle. So in order to prove that it's a rectangle, we have to show that it's a parallelogram, which we already did, with a right angle. If we look at the slopes that we have here, okay, one is 3 over 5, the other is -5 over 3. These are opposite reciprocals. And because they're opposite reciprocals, then that tells me that MA is perpendicular to AT, and therefore angle A is a right angle. Similarly, MH is perpendicular to HT, and angle H is a right angle. So because MATH is a rectangle, right, meaning it has a right angle and it's a parallelogram,